So, in talking about graphing radical functions, I want to take a look at this guy, which is strange that I want to look at it because it's not a function. Hopefully, way back when you guys recall that a function is when we have a relationship between x and y values where the x's don't repeat. And so what happens here, in this case, it's a little bit easier to plug in y values and calculate x than it is to plug in x values and calculate y. So let's just pick a few values. So I'm going to go ahead and try, let's try 2 for y. If I do that, I get, that'll be 4 times 1/2 is 2, so that x equals 2 also. And then let's try -2 for y. And if I put -2 in for y, I get 4, and again I get x equals 2. So I have this problem that my x repeats. The other thing is that if I go to graph this function, we'll see in a second, it does not pass the vertical line test, but let's watch and see. Um, in order to graph this function, it'd be way easier if I was to solve for y. So let's go ahead and let's try doing that. I'm going to first go ahead and multiply both sides times 2 to get rid of the 1/2. And that gets me y squared equals 2x. And then we're going to go ahead and take the square root of both sides. And I want to remind you guys that when we take the square root while we're solving, we'll go ahead and make the right-hand side plus or minus. And then we'll end up with y equals plus or minus square root of 2x. Now in the past, we never really had some big consequence from having this plus or minus. We just simply said, oh, I've got a positive answer and I've got a negative. In the projectile motion problems, we said, well, we can't have negative time, so we threw away the negative part. But here, we're concerned about both the positive and the negative parts. In other words, what we really have here is this. We really have y equals plus square root of 2x, and we have y equals negative square root of 2x. And we're going to go ahead and put these guys on a graph, and I'm going to show you what they look like. And you're just going to sketch the best that you can. Okay, so check out this result. If I go ahead and I type y equals square root of 2x, I get this. And let's go ahead and make it a color so that we'll call that guy red. And then if I type in y equals negative square root of 2x, I get this. Let's go ahead and make this guy a different color, like green. Okay, and so what I have now is between the red line and the green line, I've got a parabola. So that's kind of a neat result. It turns out, you might recall that when we first started studying parabolas, we had something like y equals x to the power of 2, and that gave us a parabola that either opened up or opened down, depending on whether the coefficient, the leading coefficient, was positive or negative. Well, it turns out we have the same issue when we have x equals y to the power of 2. Okay, when we have x equals, let me go ahead and turn some of these other things off so we can get them out of the way. When we have x equals y to the power of 2, we also get a parabola, except it faces to the side. And if the number in front of the y squared is positive, it opens to the right. I'd like you to take a moment and pause the video and write this down. And then if the number in front of the y squared is negative, the thing opens to the left. Now I can tell you right now, I'm anticipating a question like this on the test. What I'll have you do is there may be a whole bunch of stuff going on. There could be like, I don't know, it could be like the equation could look like 1 divided by 5. Maybe you have a negative sign here. Maybe over here we have a 3. Maybe we even have something like -4. And and I might ask you, which way does this thing open? Does it open, you know, up, down, left, right? And I'll expect you to be able to figure that out. So anyways, again, this guy, if we go and look at it in Desmos, we can see it certainly looks like it opens to the left. If I just went and changed this guy, well, actually, if I change this guy right here, oh, why is it? Why is it that it opens to the left? There's a positive number in front of the y squared. It's because a lot of other stuff is going on. So we really need to get the parabola to the point where x is all by itself. And then when we do, then we check to see what's the number in front of the y. And in this case, it would be a negative number. So let's see what happens if I get rid of this stuff. Let's get rid of the stuff that's in front of the x, make it a whole new problem. We'll do something like plus 5, and then instead of having a 3 here, we'll have something like 1 over 2. And let's go ahead and plug the negative sign in. So again, we open to the left with a negative in front of the y squared, and we open to the right with a positive in front of the y squared. Okay. Oh, now, how does all this relate to what we were just talking about with the square roots? Well, again, this guy, x equals y to the power of 2 is just two separate equations. If we go to solve it for y, we get y equals square root of x, and we also get y equals negative square root of x for the same reasons that we just mentioned, that when you go to solve this, you get plus or minus square root of x. And if I get rid of this, you can see you get that parabola. Okay, I wanted to make sure that you guys knew that you could have an equation where x equals y squared, or x equals 3y squared plus 7, or a variety of other things. You could have negative 2. And either way, oh, let's take a look and see what these guys look like. Let's get rid of those. When we have all this stuff, we get parabolas. And same thing, this guy is still going to be like our kangaroo. It moves the thing up and down. I'm sorry. Oh, in this case, oops, that's not like the kangaroo. It's interesting. It's worth experimenting with. This guy actually moves the thing right and left. This is no longer the case. Now, don't worry about that. That's not going to be the main issue. All I want you to know, I just want to be able to, I would like to be able to get you guys to tell me if you have something like x equals y to the power of 2. In other words, if x is all by itself and the y is squared, I'd like to know, does it open to the right or to the left? And if I have y all by itself and x squared, I'd like you to be able to tell me whether it opens up or down. And again, if you want to see that, if we put a negative sign in front of the x squared, it opens down. Positive, it opens up. With the y squared, if we have a negative in front, it opens to the left. Positive in front opens to the right.